Okay. Yeah, so let's just we'll do all the free response. And the thing is, y'all, that number 1 and number 3 are repeated in the multiple choice. So, get those because they're going to be repeated. Oh, I can't see that, can you? Number 1 and number 3 are going to be repeated. Number 1's, I think it's pretty easy. You just using the lens equation, really. So I have, this is P1 is equal to 20 and F1 is equal to 10. So in order to find Q1, I just say 1 over 10 equals 1 over 20 plus 1 over Q1. That's 2 over 20 minus 1 over 20 is equal to 1 over Q1. So Q1 is equal to 20 centimeters. That means that and then also M1 is negative Q1 over P1. That's negative 20 over 20, which is negative 1. All right, that's just like I just forgetting about the second lens, just looking at the first lens. And then my image then is going to be 20 centimeters to the right of this. It's going to be inverted because the magnification is negative, and it's same size as the object because the magnification has a magnitude of 1. So this is 20 centimeters. That's this number right here. That means that this number, P2, is equal to 50 minus 20, or 30 centimeters. Okay? Then I do the whole thing over again. I say 1 over 15, that's F2, equals 1 over 30, that's P2, plus 1 over Q2. That's 2 over 30 minus 1 over 30 equals 1 over Q2. I just found the common denominator. Make sure you can do that. I guess you can do it in your calculator, but I think it's easier to do it that way. Whatever y'all think is fine. Q2 is equal to 30 centimeters. So M2 is equal to negative Q2 over P2. That's 30 over 30, which is negative 1. So that's our M2, M1. That means our M total is the product of those two. It's going to be positive 1. So the position of the final image is this Q2, 30 centimeters to the right of the lens, and then the total magnification is plus 1. Yours is going to be basically exactly like that, except just the numbers are different. Okay? And then the second one, this one isn't hard. It's the first part is you have to identify the mirror. All right, so you need to know those different lenses that are made by mirrors. And yours is a mirror question, just like this. So I can identify this because it is upright and bigger. And that's going to be the mirror that's concave, where I'm inside the focal point, and it looks like that. Okay, so this is the object, this is the image. The other alternative, being upright, is a convex mirror, but in that case, there's the object, and then the image is smaller. So the bigger part is important. I know it's bigger because this is the object and this is the image, so it's 4 times as big. All right, so the first is that it's concave. You don't need to write this, but it's inside the focal point. There will be some questions like that too, by the way, where I ask you, hey, this is the type of image formed. What is the mirror or lens? There are 2 or 3 questions like that in the multiple choice. All right, so now I want to set up a system of equations. I know that the magnification is equal to, what, 12 divided by 3? The magnification is equal to, magnification is equal to 12 divided by 3. That's HI over HO. That's equal to plus 4. And then also, I know that 1 over F is equal to 1 over Q plus 1 over P. But I know the center of curvature is 40 centimeters. So F is equal to C divided by 2, which is 20 centimeters. And because it's a concave mirror, it is a positive value. Watch that, okay? Because if it was a convex mirror, it would be negative. All right? I don't remember what I gave you, but if it was convex, I'm going to put here 1 over 20. Now I have a system of equations. Or I can say 4 is equal to negative Q over P, and 1 over 20 equals 1 over q plus 1 over p. I have a system of two equations with two unknowns, so that's solvable. Easiest way I find is to say that q is equal to negative 4p. I just cross multiplied that. I don't know if I know cross multiplication. Oh wait, I don't have to deal with any fractions. And then I can take this and plug it in for q right here. So I get 1 over 20 equals negative 1 over 4p plus 1 over p. Then I want to find a common denominator. That's going to be 4p. So this will be 4 over 4p. That's 1 over 20 equals 3 over 4p. That's 60 is equal to 4p. So p is equal to 15. I'm not looking for the object distance, so I'm looking for the image distance. But that's easy. I can just put in that 15 up here. So q is equal to negative 4 times 15 equals negative 60. All right, so that's the answer. It's 60 centimeters. Because it's negative, it is to the right of the mirror. 60 centimeters to the right. Okay? Yes, we're good? I know this is fast, but all right. And then this one, your first step is find the slit spacing. A, that's 1 over 8,000 in centimeters. That's equal to 0.000125. That's in centimeters, though. You'll definitely need it in meters, so it's 0.0000125 meters, or 1.25 times 10 to the negative 6 meters, 1.25 microns. All right, that's the first part. And then B, I want to know the distance to the central maximum, from the central maximum to the second bright spot. So let's just gather everything that I know. I know D. I know M is equal to 2. I know that wavelength is equal to 600 times 10 to the minus 9. It's in meters. And I know that L is 2 meters. 2 steps. First, find theta. So D sine theta equals M lambda. I'm looking for theta. Theta is the inverse sine of M lambda over D. M is 2. Lambda is 600. Divided by D, which I've already found, 1.25 times 10 to the minus 6. I like to cancel out these. 10 to the minus 6, 10 to the minus 9 gives me 10 to the minus 3. It just helps me when I do my order of operations. So the inverse sine is 1200 times 10 to the minus 3. Oh, that's 1.2 divided by 1.25. I get 74 degrees. And then to know y, I just say L tan theta. That's going to be L, which is 2 times tan, 74, 7 meters. Well, that's a big diffraction pattern. 7 meters. That's right? Y'all aren't calculating. Okay. I'm pretty sure those are right. And then finally, you're going to have to draw 2 rays and describe the image. This is a convex mirror. It could be a mirror or a lens, and any one of the really 6 scenarios. This is one of the harder ones. So I could draw a ray that's parallel to the axis, and then it would go through the focal point, but this is a diverging device, so it's going to go through the focal point like that. Okay. You could go through the focal point. Probably an easier one to do, though, is to go to the center of the mirror, and then it just follows the law of reflection. And then I trace the reflected rays back. Like this one gets traced back, and this one gets traced back. So this is where my image is. And it's an upright, smaller image, as I would expect. There is another ray that I could draw. That would be through the focal point. That is, I would draw a ray such that if I were to trace it forward, it would go through the focal point, and then it would go parallel to the axis. So that's where it crosses right there. All right. There are videos for each of these on the homework assignments on the website. So if you're unclear on how to do those, look back at that. If it's not clear in your notes, you only need to draw 2 rays. Pick the 2 easiest rays that you like and just work on those. Don't try to get all the rays. You just confuse yourself. That's not really necessary. Well, I take that back. There is a multiple choice question where I ask you which of these rays is correct or incorrect. And so that would require you to know all the rays, but you won't have to draw them. You just have to identify them. Is that clear? Okay, that's a lens or a mirror. All right, that's all the free response. And this image is virtual, upright, and smaller. You should be able to identify that for all of them, except for the concave mirror and the convex lens when I'm outside the focal point. That can produce an image the same size or bigger or smaller. It depends where it is. I'll just ask you, is it virtual or upright, real or inverted? Alrighty. All right, what about the multiple choice? Again, it'll look a lot like this exam. I think the 2 lens is the first question, stuff about spherical aberration, just sort of basic things about lenses and mirrors using the lens equation. There's a lot of using the lens and mirror equation. You probably have to do that 6, 7 times on the exam. So make sure you can handle that equation well. What, Lake? Right? Rain? Right? Yeah, right. Yeah. Okay. Particular multiple choice questions? 2020? Yeah. This one? Yeah, this would be more like your free response. So it's a good example of the free response question. Um, First, you need to identify what type of mirror this is. It produces an upright image, so it's either convex or concave. Convex produces upright, but concave also when it's inside the focal point. So then, is the image bigger or smaller? The object is 8 centimeters high. The image is 4 centimeters high. So this is a convex mirror. It's like this, where the object is here and the image is there. So the center of curvature is 8 centimeters. That means my focal length is equal to -4 centimeters, half of that. The magnification is equal to 1/2. It's +1/2. And I think that's all I know, right? Then I set up my equations. I say 1/2 equals -q/p, and then 1/f is equal to 1/q plus 1/p. And I'm looking for q. So I could say p is equal to -2q. That's what I did there. I cross multiplied. I multiplied those 2 numbers, and I multiplied those 2 numbers. I just solved it for p. And then I plug that in over there. I get -1/4 equals 1/q minus 1/2q. Find the common denominator, which is 2q. So I get -1/4 equals 1/2q. So q is equal to -2q. -2? Yeah, -2. So it's 2 centimeters to the right of the mirror, right there. Okay, that's just like your free response. You wouldn't have that on the multiple choice, but that is a good example of a free response that you could have. The -4 for the focal length. Yeah, I was told. Yeah, because this is the center of curvature is 8 centimeters, and the focal length is c divided by 2. And then the negative, that's so important. The negative is because it's a convex mirror. Yeah, okay. It's a convex mirror. Please don't get that wrong. Like, know that table that I gave you on day 1 of chapter 7, where you see all the various focal lengths and the way the images are, that's very important. It's important not just for this question, it's important for a number of questions. So knowing that table might be the most important thing for this exam, or at least for chapter 7 of this exam. All right, that's a great question. Thank you. It's a subtle question, but if you get it wrong, then you get the whole thing wrong. You don't like that, do you? Yeah, it's important. That's why I'm stressing it. Know that table. Know it really well. Okay? All right. 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 Okay. What else, y'all?
You can do 15 on spring 24.
15 on spring 24. Okay. Yeah, we did one like this in class, but this is similar to what you'll have to do. Like it's a sort of a basic diffraction grading problem, but it's a little more subtle than that. What I'm looking for is when I ask how many bright spots, is I'm trying to solve for M. I want to know what is the order number. What order number is there? And then also, when I'm asking how many bright spots there are, like what is the maximum number of bright spots, I'm going to assume that theta is equal to 90 degrees. Because if you think about it, it's a double slit. They're my interference pattern. That this is my angle theta. But if my angle theta is 90 degrees, that light is no longer going to the screen. That light is actually going behind the double slit, or the diffraction gradient in this case. So it's like a limit to where my diffraction pattern is. So I'm looking for M, and I'm setting theta equal to 90 degrees. So if you see this question, how many bright spots are there? Think, oh, set theta equal to 90 degrees, and then calculate for M. That's your MO for this. So I know that d sine theta equals M lambda. Sine of 90 is just equal to 1. So M is just equal to d divided by lambda. D is 8.3 times 10 to the minus 7. And lambda is 436 times 10 to the minus 9. 6 times 10 to the minus 9. And that gives me 830 divided by 436. I get 1.9. That's 1.9. So then you need to remember that bright spots are like children, right? You can't have a half of a child. Even though it seems like it would round up to 2, that you really round it down. So 1.9 would round down to 1. And then imagine your interference pattern. There's the central bright fringe. This is M equal 1. M equal 1. So on my screen, I'm going to have 3 dots. All right. It's kind of a complicated question. You need to know that when I'm looking for the total number of bright spots, that the extreme of this is that theta has to equal to 90. That's like a limit, if you will. And then solve for M, and then I get M is equal to 1.9. Then I round that down. I was like, oh, I'm only going to see the first order. But I actually see 2 first orders because there's 1 on either side. And I see the 0th order as well, or that central bright fringe. So I actually see 3 bright spots on that screen. Okay. Then there will be, honestly, I don't remember if I put a question like this on the exam. I don't remember that. But I do know that there are several that are sort of, what is lambda? What is theta? What is y? All right, so there are several of those between the free response and the multiple choice. I don't remember if this one is on there. All right. Honestly, like your exam is a lot like this one. Yeah, I mean, exams 4 are pretty consistent throughout the years. So you can probably pick any one exam and you won't really find any questions that won't be on your exam as well. I think that's true. I don't think there's really anything that I've not done. Okay. What else, y'all?
Can we do the one where it's like if you add these two together, what does the final one look like? It is like a boxy way.
Oh, yeah. Mhm. Like this one? Yeah, so just take it piece by piece. Like for example here, this part combined with this part, I have a big in the positive and a small in the negative. So it's just going to provide a little bitty blip right there, right? Like if you imagine that this is 2 units tall and this is -1 units tall, then I'm going to come up with 1 unit tall. Notice how this little blip is half the size of this blip. And then it looks like that's the only option, so it has to be B. But I can look, see, these two cancel out. This cancels out with that little part, and then I'm just left with that, which is that piece right there. So B is the right answer. Just take it piece by piece, and notice that some of them are positive and some of them are negative. And if they're equally positive and negative, they'll cancel out. Or if one's more positive than the negative one, it'll have a smaller piece in the positive. Okay. Make sure you know how to do this. Right. I have 0 wavelength difference, 1, 2, 3, 4 wavelength difference. So if this is 1, that's 1.5. Make sure you know how to do that. She undid this too. There was something that we haven't done in class yet. What was it? We're going to do it today. That was on the exam. I think it was something like 17. Not exactly like this, but something similar. What happens in the double slit apparatus when the distance between the slits is doubled? So imagine that d sine theta is equal to m lambda. If I increase the slit difference, that's going to decrease the angle. That means that the pattern is if I make the slits farther apart, the pattern is going to get closer together. It's inverse. We'll cover this in class today, but there is a question like this on the exam. So if D goes up, theta decreases. And also the distance between the slit, between the dots on the screen decreases. We could see this with other things too. Like if I have d sine theta equals m lambda. What happens if lambda goes up? What happens to the pattern? Does it get farther apart or closer together? It gets farther apart because if lambda goes up, sine theta goes up, which also theta goes up as well. So if lambda goes up, if the wavelength increases, the angle increases, and that means that the spots are going to move farther apart. I think that's really all I could ask. What happens if the separation between the slits increases? The pattern gets closer together. If the wavelength increases, the pattern gets farther apart. But when I ask that question, I will just write the equation right here, and then write the equation, and then ask how the variables are related to one another. All right? We'll talk about that in class today because we haven't done that exactly. But I think everything else we've done. I did make the concept tests available, but we'll go over them a little bit today. I'll just sort of hit the high points. Y'all feel okay about this? If you know the lenses and mirrors, I see you just like anything. If you know the lenses and mirrors, it won't be a hard exam. I mean, if you also need to know the diffraction, like how to do the diffraction gratings and stuff, but I think that's really not that hard. In fact, it's a smaller part of the exam. I think there are 12 or 13 lens and mirror questions, and then 7 or so diffraction questions, because we just haven't spent as much time on that. Ethan? Yeah. So you will see one like that. It won't be like exactly like that, but let me show you what it will be like. I'll give you 2 waves, and I'll tell you what I tell you. Yeah, I'll tell you their wavelength. So let's say, for example, you have two waves. I don't know, the wavelength is 4 meters. One travels a distance of wave 1 travels a distance 8 meters. Wave 2 travels 4 meters. That means that the path length difference is 4 meters. That is, 8 minus 4. One travels 8 meters, one travels 4 meters. The difference in those two paths is 4 meters. Then you ask, this is what multiple of this? That means that the path length difference is equal to 1 wavelength. If I have 1 wavelength, that is constructive interference. I get a bright spot. If it was a half a wavelength, or 3/2 a wavelength, or 5/2 a wavelength, that would be destructive interference. Let me look for a question here that's similar to that. Those aren't super common in my past exams, but you will see it. It will be common on Monday's exam. Well, here we go. Number 18. What is this? Spring 21. Number 18. Two waves are initially in phase and have a wavelength equal to 0.5 meters. Make sure I didn't stop that. One wave travels 3 meters, another wave travels 4.25 meters. So the path length difference is 4.25 minus 3. That's 1.25 meters. That is what? This is equal to 2.5 wavelengths. So at that point, I'm going to get a dark spot. So number 18 is D. If it was, what I did there is I said 1.25 divided by 0.5. And that's equal to 2.5. That's 2.5 wavelengths. If this were 2 wavelengths, I would have gotten a bright spot. Any half wavelength increment, I'll get a dark spot. Anything else, I'll get a gray spot. That is just sort of in between, is what that means. Not bright, not dark, in between. Okay? And then D, that's not right. You will see one of those. We'll look at those today. There's some in the concept test. All right, y'all. Let's see. Any other questions? Let's see if I have any questions I want to. There are only 19 questions, so, and then there's a freebie. I don't think there's anything. There's nothing about the eye. We didn't cover that. Did we? I don't think we did. I think I skipped over it. So nothing about the eye. Is that right? Let me double check that. Nope, nothing about the eye. Any other questions? All right. I didn't get, I mean, make sure I get everybody before y'all leave, okay?